Hi everyone, so I wanted to make a second video to kind of go back and describe the intuition behind calculating our partial derivative with respect to weights with this x term. So in the previous video I go into detail with using this first model and calculating the partial derivative of our loss function with respect to weight 0, but I never went into what it looks like for weight 1, or what if our model looks like this and we have weight 2 or weight 3. So I'll do that kind of right now, and there's no code in this video. It'll just be like showing the math and then the notation with it as well, right? So if this will work, here we go. Okay, so last time we went over that first model, right? So our error looks like this, and if it's kind of confusing of where this comes from, it's basically so we have our error and we have our actual y minus our h of x function, which is our y estimate. Right, so you're basically doing y minus this. So that's why it has a minus weight 0 minus weight 1 times x. Right, so that's how we kind of get this, right? And then we're squaring it. We're writing out the square. We're multiplying it all out. I highlight and bold, or I guess I bold the parts that matter to us, which is if we're taking the partial derivative with respect to weight 0, then these are the only terms that we care about because it's the only ones that have weight 0 in it, right? But what if we want to take the partial derivative of our loss with respect to weight 1? That would look like this, where you still factor out a -2 and take it out of the summation, but now you can factor out the x. So if I pull up, let's see, we can kind of just start with for n is equal to 3, right? So when n is equal to 3, we have this model right here, right, which is our bias plus all the weights times our training data, and every iterative it's giving a n plus 1 exponent, right? So this is our error, which is y minus that h of x function, and then it's squared, right? So if we write it all out, it looks like this, and then if we multiply, then we end up getting this really long term. If you're like me and you see all this, it kind of makes your brain kind of freak out, but it does help to highlight. So we're taking the partial derivative with respect to weight 2, right? So anything that doesn't have a weight 2 in it, we don't care about it for this. So this one has weight 2 in it, this one does, this one, and then the last one, right? So if we do partial derivative of this one, then we end up getting 2 weight 2 times x to the power of 4, right? Because this is squared, the 2 comes down, and then you take the 2 minus 1, right? It's just calculus. And then you just keep going, right? This one just becomes 2yx squared, and then this one becomes 2 times weight 0 of x squared times x squared, and then this one is 2 weight 1 x times x cubed, and then you drop the weight 2. So now that we have it in this kind of pretty way, we can still factor out the -2, but then after we factor out the -2, we're stuck with this. And so with this, you can factor out the x squared And then so x is not a constant, so you don't take it out of the summation. Technically, there could be like a little I right here because x is our training data. But here you can factor out the x squared, and then it kind of gets you something like this, where we can rearrange it to look like this, which is just our error. Same kind of formula right here, which is the -2 times the summation of our error times xj. Right, so I figured, maybe we can try it for another model, and I can just kind of show you the steps. So if we have n is equal to 4, let's see what that looks like. So if n is equal to 4, our model looks like this, right? It just adds on another weight and then x to the power of 4. So if we go back to our Word document, and I'm just going to be kind of copying and pasting from the previous part. So this is still squared, and then minus, we'll have minus weight 3 to the power of 3, right? So if we go back to this, and actually I need to add on another one. So come on, weight 0 minus weight 1 times x minus weight 2 times x, and then minus weight 4 times x to the power of 4, right? This is squared. So this is our model, right? Where we'll calculate our gradients for, update our weights to fit a line, okay? So now, if you were to write out that square, okay, then it looks like this, right? You're just multiplying this by itself. So now, instead of doing the calculation in like live on video, we can go to our dear friend Symbolab and just square it. It'll give us this times this, very, very long, very, very, yeah, very, very long. But if we can copy and paste this, maybe copy this first, put it right there, get rid of all this, and hopefully you're kind of seeing like what I'm doing. So if we take this bad boy, and let's see if I got everything. Okay, drop that down, paste that in there. Super ugly, but this is something that we can work with. Okay, it's already simplified because of the Symbolab calculation. So now we want, here, I'll take this and put it right there. And so now we want the partial derivative of our loss with respect to weight 4, right? So if I get rid of this, it's easier just to kind of like highlight. So wherever I see a weight 4, I'm going to bold it. Weight 4, weight 4, weight 4. There's a lot of weight 4s. Okay, weight 4. Another weight 4. This one does not have one. This one does not have one. This one does not have one. And we'll keep going, we'll keep going. Weight 2. Dun, dun, dun. Okay. I think I think I see them all, right? So now, if we just focus on this one, we'll end up getting this as our partial derivative. Boom. I don't know if it's messing up. Here, we can just type it. So it was minus 2yx, and then x is to the power of 4. I don't know why it's doing that, but so the weight 4 drops for this one. So I think, let's see. Okay, so pretty much every single one that has a weight 4 is going to drop except for that last one. This one gets added, and then here, you know what? I'll just copy in this. Okay, put our parentheses, and looks really ugly. This is just kind of errors. It did not copy and paste very well. I might pause the video real quick and fix this. Okay, I think that I have a pretty good way of typing this all out. So I have this first one, which is that. The second one, which is this, where you just dropped the weight 4. I have that one, which is 2 times weight 1 times x to the power of 5, drops, and then you drop this part. Okay, so now we're on this one, which would be 2x to the power of 6 times weight 2, and then we have, so you drop the weight 4, and then we have this one, which would be, I think I have all my pluses correct, and then this one had a minus. You would have 2 to the power of x to the power of 7, weight 3, okay, and then we have our last one, which is, oh yeah, this one, which is x to the power of 8, and the 2 comes down, and then we don't have a weight. So hopefully this makes sense, right? So this one is x to the power of 8 times weight 4 squared, right? So since it's squared, the 2 comes down, and then you have this, and then just 8. Oh, and actually it has weight 4. Boom. So kind of like that. I think I have that correct. I'm pretty sure. And I guess to make it like the other ones, we can do it like that. Okay, so assuming this is correct, we can now factor out our -2, right? So if we take this and we copy it, put our -2 right there, that becomes that, this becomes negative, this becomes negative, this becomes negative, okay, this becomes negative, same thing, and then this becomes negative, okay? So now we have something like this, right? Which now we can factor out x to the power of 4, and let's copy that right there, and let's put parentheses around this just to make it easier on the eyes. So if we factor out x to the power of 4, then that goes away, that goes away, that becomes just x, this becomes x to the power of 2, x to the power of 3, okay, that goes away, and then that becomes x to the power of 4. Let's see if we have this correct. I might pause the video again just to make sure. Okay, so what I think, I have no idea where this came from. So if we take that out, I don't even see that in there. So take that out, and then take it out of here. You know, this is our error, right? We have y minus weight 0 minus weight 1 times x minus weight 2 times x squared. This is our error, right? And then we have that x to the power of 4 right here. Okay, so we pretty much did it. Like I'll show the PDF again. So if n is equal to 4, right here, right? So minus 2m times the summation of our error times x to the power of 4. So yeah, we did it. So if you have any questions, hopefully this was smooth. It was, you know, just doing it on the fly again, but hopefully this kind of spells out like exactly what you're seeing when our model changes or when we're doing a different weight. So thank you.